Hello, and welcome to another webinar in our series on what's new in SAP HANA 2.0 Service Pack 8. My name is Vitaly Rudnitsky. I'm one of SAP developer advocates, and I'm going to host these sessions. Just as a reminder, if you watch this live and you would like to participate in the discussion, then use the live chat on YouTube video. Please ask your questions there, and our presenters will be happy to answer them. Today's sessions is about the supportability tools and what's new there, including VS plugging and SQL Analyzer. We have people from SAP HANA team, and let me hand this over to them now.
Hello, my name is Taesok Son, and let me just share my screen first. So for today's session, we're going to talk about briefly about the new features around the HEX execution engine, and also the supportability around supporting the HEX execution, using the SQL analyzer to look into the HEX execution. And then finally, my colleague, Zhang, will present the new supportability tool. So to go into the topic, so like I've mentioned, today's agenda will be briefly, we'll touch the HEX features and the supportability around it, the SQL analyzer, and the supportability tool. So with SPS 08, we had put in a lot of new HEX features to enable your existing queries to execute using the HEX engines. So some of the features are listed here, like anonymization views, distributed queries where the results are streaming, dynamic pruning.
So
Yes.
it seems you haven't shared your screen yet.
Oh, sorry. I thought I did. Is it viewable now?
Yeah.
Okay, sorry for that. So we have many X enablements or new features that are delivered as part of the SPS 08. So the features that are enabled with SPS 08 are listed here. So we support like aggregate functions, window functions. We also support built-in functions, and also for user-defined functions, and supporting like lateral join, range join, calc views, etc. So previously with SPS 07, that is the version where we initially started supporting some of the OLAP-based queries, more complex queries, and customers may have noticed that some of their existing queries have begun executing in HEX. But with SPS 08, you will see more of these queries now being able to run in the HEX execution engine. And in addition to that, we also made performance improvements. So we used the existing S4 workloads that we have, and we use those workloads to fine tune the HEX executions. And we improved some of around the workloads, such as distributed queries, various cases of group bys and joins when it's using internal tables, top K queries where there's more than one sorting columns. So based on all different S4 workloads, we had made sure that we made improvements in the performance of the execution engine. Well, based on that, some of the customers using SPS 07 may have noticed that prior to the SPS 07 upgrade, their existing queries had been running in the join engine or OLAP engine. And after they've upgraded to the SPS 07, that these queries, some of the queries have been executing in hex. And it was executing really fast. But one of the, for on-prem systems, unlike the HANA Cloud, we try to make sure that we're not introducing regressions into the on-prem system, because the install base of these on-prem systems are very large. And also, these systems are most likely mission-critical systems for customers. But when these queries are executing in hex, most likely it would execute faster than the existing join or OLAP engine. But to make sure that we're not introducing regressions, we have threshold limits that are set. So if the intermediate result set exceeds the limit, or the input data exceeds these set limits, we make sure that to use the older engines like the join engine or the OLAP engine, so that we're not introducing regressions into customers' system. But after the SPS 07 upgrade, customers have experienced the benefit that hex brings forth with the faster execution engines. But during run execution, some of the queries that are parameter-based and based on the parameter values, the result set may exceed the limit. For this situation, as explained in the left flow chart, if it hits the hex limitation, then we invalidate the plan, and then we compile as the old plan. This is to safeguard that we do not introduce regressions due to a large data set. But for customers who have already experienced the benefit of hex, may also consider this a fallback in the performance, or consider it as a regression in performance, because during the SPS 07 execution, that mostly was running fast, but suddenly it's running slow again. So this is to safeguard the existing system for regressions, but this fallback was considered another regression to the customers. So to avoid this with SPS 08, so the same thing is that we check and make sure that if it's within the limit or not. And if it is hex capable, then we execute as hex. But if it is not hex capable, meaning that there are some features still not being executable by the hex engine, then for those queries, it will still compile as one of the older engines. But as long as it can compile as hex, we will compile and execute. And if it successfully finishes the execution, then it will be cached and always run as hex. Whereas if the initial run still meets a threshold limit, then for the first execution only, that we will invalidate it and compile as one of the older plans. So with the SPS 08, the fallback issue has been resolved because we removed the runtime limit. So as long as the hex has been compiled and executed successfully, then it will always execute as a hex engine. In addition to that, customers may see performance fluctuations due to different parameter values. So due to the data skewness, one parameter may have a data skew where the performance is not optimal and running very slow due to a specific parameter set. Because the existing plans, we only compile and cache one plan for a single statement hash. And each of these can have different parameter values, resulting in different data statistics. The outcome can be different. So to overcome this, we've introduced the plan variant, and it was introduced with the HANA Cloud as well, but we also introduced this into the SPS 08 version. So just to briefly explain what plan variant is, so for a query that is parameterized, we compile and make sure that the parameterized query can be run and executed in hex. So it only covers for hex executions. And we check the, the clustering factor of the selectives. So for the predicate, we select two predicates that has clustering factors. And based on that, we execute and it compiles as this SQL plan for the parameter 1 and parameter 2 in this vector space. And then we execute another parameter set, which compiles into a different plan based on these selectives. And then we execute again with these parameter sets, but this time it actually compiled as plan, the same plan as plan 1. And this, we combined it and we put it in an Eclipse form in the vector space. And then once we execute another one, which turned out to be plan 2, and so it creates another Eclipse space in the vector space. And for the fifth execution, if it's within the Eclipse, then we consider it a cache hit at this time. And for this one, we use the plan 1 that is available in the plan cache. So basically, for the same statement hash, for this example, we have two plans that are cached in the SQL plan cache. And when we're using the plan variant, as you can see, because we're only using one execution plan, the outcome is very diverse in the performance. But once we started using the plan variant, the divergence of the execution have been narrowed down and the performance have improved overall as an average when using the plan variant. So to just briefly go over the plan variant again, during the first compilation, we collect the variant filters and we start calculating the selectivity distribution of each of the table filter. And then we determine the highest score that exceeds a set threshold. If there are no variant filters that exceeds the threshold, then the plan variant will not be utilized. One of the reasons that we're doing this is because when you're using plan variant, there will be multiple compilations. So reusing a optimized plan improves performance, but there is a penalty of having multiple plans being compiled. So if there's no benefit of using the plan variant, we shouldn't use the plan variant for such cases. And that's why we make sure that we have a situation where using the plan variant actually can improve the performance. And during the execution itself, we calculate the selectives of the parameterized table filters, and the default is 2 filters as shown in the previous example. And then we go through that comparison process that I've explained in the previous slide. Now, how to use the plan variant. So basically, the plan variant is introduced using the plan variant hint. This hint is needed because we don't want to introduce any possible regressions if we execute plan variant by default. So for SPS 08, it is a hint-based action that is needed from the customer to add this hint to a known fluctuating query that is parameterized query that you would add this plan variant. If you want to check if the plan variant is actually being applied, there's a precompiled plan variant shown in the explain plan, where using the explain plan, you can check if the plan variant is actually being utilized. And there are additional monitoring views like the MSQL variant statistics, which is independent of the MSQL plan cache, because for each plan variant, it would have different statistics. That's why we have introduced additional monitoring views for the plan variant as well. In addition to that, like I've mentioned, the plan variant is using a hint. And if you want to specifically define a column to use as the selectivity filter or vector, then you can name those columns within the hint itself. If you don't want to use the plan variant, then you can use the no plan variant hint. If you don't want to use a specific column, you can add that into that no plan variant hint. And also there are options to increase the number of the filter count, variant filter count, and also the number of plans that are cached within the SQL plan cache. But keep in mind, adjusting these values will increase the complexity of the plan variant, meaning it can decrease the performance if you have too many variant filters or too many plans cached within the SQL plan cache. Now, also from a supportability perspective, we made some enhancements around SQL execution supportability. And one of them is to know why hex was not used. It may be due to some features not yet available, or the column type is not supported by hex, such as spatial. So if you have a spatial column in your table or in your query, then for this case, currently we do not support it executing in hex. Also, if the reason shows exceed input limit or exceed output limit, then this will mean that during the compilation that it exceeded the threshold that we have set. And for these queries that it will be compiled as one of the older plans like the join engine or the OLAP engine. And also for the parameterized queries, we need to understand what was the last invalidation reason. But due to the characteristics of the parameterized query with the pre-initial compilation, that some of the information gets lost. So to overcome this, we've also introduced a new feature called Plan Decision Recorder. So this Plan Decision Recorder is actually logging the information, the minimal information when a plan gets compiled. But since this is adding additional trace information into the system, by default, it is turned off. And to activate, you would need to change the configuration to turn on the SQL Plan Decision Recorder. Also, we've downported to the SPS 07 version as well, so that for customers who are already using the SPS 08 can also use this Plan Decision Recorder for pinpointing any performance issues that they have noticed due to plan changes. And within this configuration, there are also several other configurations that can be utilized, like storing the hex rejection reason. So like I mentioned, why it was not compiled as X, those information can be also kept in the trace log. Also, by enabling the parameter values, it stores the values of the parameters. So these values can be used to figure out why a plan is compiled as such. Because previously, without knowing the exact parameter values, it was very difficult to pinpoint the root cause for some of the performance reasons why such a plan got compiled in a certain way. And to figure that out, we needed to know the exact parameter values. And this gives the option to store those values in the trace files. And in addition to that, you can enable statement string, and also you can enable to store non-parameterized query. But we recommend that to keep this information minimal, to only use it for the parameterized query. So that's it for some of the SQL side supportability based on, and to support as more and more queries are now being executed in hex, we had made enhancements in the SQL analyzer running in the Visual Studio Code to better pinpoint the performance bottlenecks. And as you may already know, this is the successor to the HANA Studio. So some customers may still be using HANA Studio to the plan viz functionality within the HANA Studio to analyze the performance of a single statement. But for Hex, we recommend to use the Visual Studio Code because all the latest enhancements around Hex is only supported with the new tool of the Visual Studio Code. So we highly recommend to now switch over to the new tool. So this is the basic layout of the SQL Analyzer. So on the left side, you have various planes to show, to read different PLV files, what are the dominant operators, what are the top 10 critical path operators, and also to increase the usability, we show the last 10 visited nodes, and also allow you to bookmark a certain operator so that when you're communicating with your colleagues or with our SAP support, that you can use the bookmark to easily pinpoint the operator that you think it needs to be investigated further. And this new tool allows you to connect not only to the on-prem, but also to the HANA Cloud. So it uses the Database Explorer now available in the Visual Studio Code to connect to both the on-prem and the HANA Cloud environment. And we've now integrated with the database SQL console. So within the DBX SQL console, you write a SQL statement, and then within the dropdown of the Analyze menu, there's the Analyze Executed Plan. And here you enter the parameter values that you want to analyze, and then you enter a prefix, save it, and then it will be automatically downloaded and opened in the SQL advisor. The SQL analyzer. Also, if you, so most of the times for the parameterized queries, you have to know what were the parameter values. And the PLV can also capture the parameter values that are used within the PLV, but you have to turn on a specific configuration. By default, this is disabled because for privacy reasons, the parameter values may contain personal information. And so by default, it is turned off. But within your company policy, if you allow such a parameter to be logged and captured, then you can turn this on. And when you generate the PLV, we will also capture the parameter values. And then when you try to re-execute, these parameter values can be reused to execute the SQL statement again. So that is it for my section, and then I'll hand it over to Hai to go over the supportability tool.
Okay, thank you, Tessel. Let me share my screen first. Okay, let me continue with the supportability part. So supportability tool is also one extension in the Visual Studio Code, and the tool is focusing on the performance analysis. And today I will mainly share two enhancements in the tool, and starting with the plan trace for online mode. In HANA database, we could collect plan trace for the running SQL statements, and then the PLV file is generated, collected. And with that file, we could use SQL Analyzer to analyze the SQL statement plan to see where is the bottleneck, just as mentioned in the SQL Analyzer tool part before. When supportability tool doesn't support this from user perspective, a user needs to first collect the PRV file from other tools, download it, and then upload to the SQL Analyzer. But since currently supportability tools support this, which means user could use the supportability tool in Visual Studio Code to enable the trace, collect the plan V's file, and then user could automatically navigate to the SQL Analyzer extension to analyze the collected SQL plan. And let me introduce some more details. So just as the attached screenshot in the screen in the slide, the first step in the supportability tool, user could start or stop plan trace by clicking the button at the right up point of the tool. And then once the user start collect the trace, try to collect that button, a pop-up window will show. And the user could define some additional filter options for the tracing. For example, filtering on user, both database user and application user is available. Also could define filtering on the application name, statement count, and statement string. And we also support two new configuration options. One is compiled queries only, which means trace only during compilation. Another is include DML statements, which is that for the plan trace, we start to support DML SQL statements. And then once enable the plan trace, based on these configuration filtering options, the related SQL statements, plan trace will be collected and saved in HANA database side, and in the UI, you can see the collected plans for the SQL statements that meets the configured options. So that's the first enhancement. And in here, the third button, open in SQL Analyzer. Once you select the SQL statement in the tool UI and click on the open SQL Analyzer, then it directly navigates to the SQL Analyzer tool to show the detailed plan for the selected SQL statement. If time remains, later I will try to demo this functionality, and also I will try to demo the second functionality, which is kind of enhancement in the offline analysis mode. And the enhancement is that as we support SQL queries on runtime dump statistics tables. And the overview of this enhancement is that we support query on statistics tables in a dump file. So in runtime dump file, there are many helpful information when do the troubleshooting and performance analysis, because many monitoring view data during the dump file collection is collected in the dump file. So, which means we could query on the many information inside the monitoring views, saving as statistics tables to do the performance analysis. And the tool also supports save queries for future reuse. For example, if you have some already written query to analyze certain performance issue, then you could save the query in the tool and reuse that for later dump files. The benefits of this functionality expected are: first, enhance user efficiency by enabling detailed analysis, because user could check the different information inside different monitoring views by different SQL operations, for example, add var condition, drawing with different monitoring views, and aggregation. All these functionalities are supported. And also, although the tool supports the auto analysis, but for many the auto analysis identify the issue, we also need to drill down to find the root cause and final solution. And this functionality could help on that part. And in the tool side, just like the screenshot shows, you could first, how this shows how you can use this functionality. First is in the dump viewer page, select the statistics viewers tab, and in there is a search by query option. If you enable that, then there is console pop up, and in there you could just write an SQL statement and run the statement to check the result. And another part is that you could save query that you have written in the console and use a query description to save the query as the query name. Then let me share some examples that how this functionality could help user to do the performance analysis. For example, user could check the memory consuming SQL statements based on a runtime dump file. So user could write such an SQL statement in the console, and this could identify SQL statements causing composite out of memory and order by the OM count by different statement hash. So how could we get this result? Because there is one more statistics table called M out of memory events in the runtime dump file, and we could select the statement hash in that statistics table and select the count of composite OM count, and then where the event region by where filtering where condition that generate composite OOM, and group by statement hash, and then order by the count, OM count, then we could get such a result just as the slide screenshot shows. And another example could be finding out the active running and active waiting threads. This information is important because we could know when the runtime dump is collected, how the HANA database situation is, because if many percentage of the active threads are in waiting threads, then it means there could be potential log situation, log wait situation. Then these information are in the threads section, statistics table, and we could select on the thread wait status count based on the thread state active. And once this is executed, for this example, as you can see in the slide, there are more waiting threads than the running threads, which means waiting threads is more than 50% of active threads. And that could show kind of potential log wait situation for when that runtime dump file is collected for the specific HANA database. And another example is to drill down auto-identified issue. And in this case, I want to use an example for the auto-identified issue, many transactions blocked. So the scenario could be one database administrator needs to investigate the tool automatically identified many blocked transaction issue to address the following points to finally find out what's the root cause and what's the solution for this auto-identified issue. The first step could be identify where the log is occurring. So is it a table log? Is it a schema log? Is it a record level log or complete table level log? Such kind of thing. And the second step is to find out who the log owner is, who is creating that log so that other users could not access the object that has been logged. And the last step could be formulate step to resolve the locking situation to avoid it happens again. And to start with the first step, identify where the log is occurring. So to find out if there is any transaction log in the runtime dump file, then there is a statistics table called unblocked transactions. In this statistic table, there are such information. So a user could select the related column in this table, for example, schema name, table name, and the waiting record ID, and log owner, log type, and count this information, and then group by the columns. Then based on this query execution result, we could find out a single record in schema SAP SR3 table NRIV is locked, and which cause other 23 database transactions to wait. And after then, we could check who the log owner is. Then we could check this based on the unblocked transactions, M transactions, and M connections. These three monitoring views data saved statistics tables. So just as the screenshot, the query, this query enables the administrator to pinpoint the application user. Application user information is in the M connections statistics table, which is PROCP, and this application user is holding the log, and also the application source information is also available in the M connections And based on that, this is ASP or SNR3 and line 1715. So how could we identify just this specific line result from the M connections? Because we know the transaction ID information from M block transactions and M transactions, and these statistics tables have the related connection ID. And based on that connection ID, we could identify the exact row in the M connections, the statistics table to get the result we need. And then what we could do, user could coordinate with colleague responsible for the application source code and the application user to verify the record log. So first, if the log is expected behavior, then if the log is expected behavior, it takes some time, and after that the log is released, then no further action is needed. But on the other hand, if the log is unnecessary, long, and impacts other users, then application side, the developer should consider modifying the application source code to minimize the log duration. Okay, then I guess there is time left, I could try to show some demo. Switching to the Visual Studio Code. So for the users who haven't used this Visual Studio Code extension, so first you need to install this Visual Studio Code software, and then there is extension tabs in this tool software, and in here you can search for SAP Supportability tool. So this one, and you can install this extension. Once you install this extension, then Database Explorer, the extension, and also SQL Analyzer extension will also be installed in your software, Visual Studio Code software. Then, as you can see, this is the HANA SQL Analyzer. This one is SAP HANA Database Explorer, and this is Supportability tools for SAP HANA. And in here, you can use both the online and offline mode of this tool. Before you could use the online mode, you need first register or add your database in the Database Explorer. So in Database Explorer extension, you can add SAP HANA database. It support both SAP HANA Cloud and SAP HANA. And for me to show in this demo, I add an SPS 08 SAP HANA on-premise database. And then in this tool, we could first create a folder. Let me create a folder for demo. And I could add the connection, which I configured in the Database Explorer, which is SPS 08. Then once the connection is enabled, you could see the color change from gray to green, which means the online functionality is working here. And first, I want to share the plan trace functionality here. It could take some time because there are many plan-based files, plan trace files collected. I think because I configure the trace too long. So maybe during this time, let me also upload the runtime dump file. I could upload a file here, import. Then it automatically analyze the uploaded runtime dump file So identify if there is any known issue there. Okay, let's first start with plan trace page since it's showing. Just as I expected, there are too many plan trace collected, so I guess that's why it takes somehow long time to show the plan trace collected. And in here you can see the collected traces. And if you select one and you want to check the plan in detail, there is a button open in SQL Analyzer that could direct navigate you to this SQL Analyzer tool to check the detail of that SQL statement execution plan. And moving back to this tool, you can start trace. And you can see this pop-up window. You can configure different filtering options, user, patient, and yeah, all the filtering option you could choose to configure and start the trace. And maybe moving to the dump viewer to share the second offline mode enhancement. So this runtime dump file auto-analysis result is generated, and based on the information, many transaction blocked issue is detected, and we want to further drill down to check the root cause, and we could move to this statistics viewer, this tab, and we could search by query, enable this option. And as you can see, I already saved several queries. For example, active threads. Once I click this, the query will be loaded to this console, and I could run this query and check, for example, the active threads and waiting threads. So this is not related to the auto-detected issue, and user could also just delete any saved query. And yeah, we could first try to locate the log, this statement, and I could run it, and it shows the result that I add in the slide. And the second one, identify the log holder and select and proceed to change to that query, execute, and yeah, we could also get the exact result as I added in the slide. So that's what the SQL statement support statistic table could bring to the user. Before that, user could only check these statistic table in table format and could not run any SQL on the single monitoring statistics tables or use these kind of joins and where group by this kind of functionality here. Okay, that basically concludes my demo here. And let me switch to the slide. And yeah, that basically all that we prepared for this supportability topic. And yeah, if there is any question, we are happy to answer on those questions.
Yes, thank you for the presentation. Thank you for all the details. There is one question in the chat. Could you suggest some resources, trainings for using this VS Code tool effectively in different scenarios? So is there any learning journey? Is there any set of blogs? Is there any documentation that would help our viewers to
Okay.
to get some more resources?
Okay, I understand that point. Basically, we regularly write blog for the new features for different tools. And for example, the supportability tool, we have overview blog post to share each detailed functionality. And for the enhancement added later, yes, we write separated blog for the specific enhancement. And also there is the official SAP help document for every tool. So that's also a reference to check to better understand and use the tools. Yeah.
But do you remember, is the specific learning journey on learning.sap.com that is discussing this tooling as well?
I think there is no learning course for supportability tool, but I'm not sure. Tesop, do you have any
Yeah,
learning
currently
course
we do
for
not
that?
have a learning journey for the supportability tool yet, but yeah, we will discuss internally and then think about how to better present these new information to the customer.
Okay. The second question was if your slides are available, is it possible to share them? If you can't share them, you can send them to me, and I would post them in digital asset
Yeah,
SAP website, and I could share the links in the comment
yes,
of this video.
sure, we will
So,
share the link.
okay. So to answer this question, these slides will be available. I will post the link once we publish them on official SAP channel in the comment below this video. The other question is, can you use this plugin with just HANA Cloud, or it can be used with on-prem HANA as well?
It could be used both on-prem and HANA Cloud.
Perfect.
Yeah, so the Visual Studio Code plugin is intended for both HANA Cloud and on-prem. But the supportability tool is not available in BOSS, so only the the SQL Analyzer is available in the Business Application Studio for the HANA Cloud, and the supportability tool is for the on-prem or the VS Code plugin only.
So it is for VS Code as a VS Code plugin only, but it can be used with both, with HANA
Correct.
on-prem and HANA Cloud. Okay.
Yes.
Thank you for clarification. There are no more questions that I see in the chat. So once again, this link to the slides and the references to this blog post mentioned by Hai, we will add them as a comment below this video recording on YouTube. I would like to thank Taesuk and Hai for a lot of very detailed and very thorough information and examples and the live demo. I would like to thank everyone who joined this session live or who is watching this online as the recording. I hope that you will find all this information useful and it will help you in your project with HANA. Thank you once again. Take care and goodbye.
Thank you. Bye.
Thank you. Bye-bye.
But I had so many screens that I finally needed to look around. Where do I press